Captain Thomas invited us as crew on this boat.
We're on an adventure to find the ancient treasure. Then, one stormy night, someone got knocked on the head and lost the treasure map.
All week long we collected evidence.
Here's our evidence.
Oh no, are you okay?
No,
What's
I'm
wrong?
hurting. My arm is hurt and I fell off a robot named Chicken Nuggies.
Okay. Do you think you broke your arm?
I don't know.
I don't know. Okay. Can you get
call
up?
the hospital?
Yeah, sure. Hello.
I need mental help.
This girl has fallen and she says she needs like an ambulance or something, and she thinks she broke her arm.
Okay. Where's your location?
In the middle of the classroom.
Okay. This hurt?
No, this is my hurt arm.
I'm aware, but this is hurt.
No, not really.
Okay.
So this is a splint.
I can't see because I'm blinded by the light.
And it's like a cast, but a little different.
Yes.
Kind of a lot different, but just a little different.
It's a cast, that's not.
Because your arm is broken. Is there anything else that happened?
I breathe like this. So,
That it might be a
Collapsed lung.
collapsed lung.
great. That is
So-
great.
With a collapsed lung, it's like there's a little hole in the bottom of your lungs, or there's a hole in your lung, and it gets stuck. So, with a normal lung, it's like you just breathe like this. That's your lung,
The
and
air
then.
gets stuck between the lungs
But
and
when
the chest
when you have
cavity,
when you have
which
the,
makes it hard for her.
that's what the collapsed lung.
So I'm gonna die.
No.
Most likely.
No, you aren't gonna die. It's just you're having a trouble time breathing, and we'll help you with your
Lung transplant.
Yeah.
After the voyage, we did a head count, and 2 engineers were missing. We found that they were located on the rocky part of the island that no human could get there to save them. So we had to program a robot to get there and save them. We made robots and bots out with 10 steps. A couple of the steps were hard making them. They have a lot of cords, motors, and they can do a lot of things. They can light up, they can sense things, and they can play music. I'm going to show you 2 programs that I made that we programmed the robots to do. First, one of the hard things about the robots is to get them to connect to your device. If you see it on the app, you have to turn the robot on and at the same time press connect. When it does that, it meant that it is connected. One of the hard ones for me was one of the steps where it told you, where the directions told you to make an ambulance noise. I didn't necessarily know what it meant, but it turns out that you're supposed to do this. That, it doesn't necessarily sound like an ambulance alarm, but that is what it meant for us to do. Second is to drive the robot. In this one, you're using a different app, so you have to turn your robot off and reconnect it on that app. Sometimes it doesn't connect, that type of thing. Sometimes you can use the joystick one, move forward, backwards, turning, in all directions. It can also play notes, as I said earlier.
We built trust bridges. We built trust bridges in order to get the robot across to the ship because the island had flooded. So we built truss bridges, and we used straws and paper clips to hold so we used paper clips to hold the straws together. So what we did, we folded the paper clips into heart shapes. And then we connected the straws to them so that way they made the shape of triangles, because triangles are the strongest shape in this case. So after that, we put cardboard over the bottom straws so that way the MBOT could go across the bridge.
This is a Ferris wheel. This is a crafted Ferris wheel that actually works. It's made of popsicle sticks and cardboard with little cups for the seats and pipe cleaners holding them up. This straw is what spins it around. It can go clockwise or counterclockwise. Use hot glue to hold up these popsicle sticks so it can stand up for structure, so it can be stable. While building this Ferris wheel, there were 4 roles that we had to take. One was the project manager, who had to look at to monitor everything and see if it was completed and get ideas from all members of the group we were in. Another one of them was a scheduler who would help the project manager and make sure that we did the steps that we were supposed to when we needed to, make sure it was on schedule. And there's also a structural engineer that had to make sure the building, the whole craft looked exactly like the first sketch that we drew for what the ride was supposed to be. And the electrical engineer, which really didn't get to do anything this project, was supposed to see and look for all parts of the project that required electricity and movement, and help with that and build that. And that's how this Ferris wheel was made, with all 4 of the roles.
One day, James was walking around in the desert, and then suddenly he looks in some grass, and then a snake bites him on the ankle. Daryl is so upset that he calls his friends. They're asking what happened, and they are arguing how to treat the snake bite. Should they suck the poison out, cut off circulation? Finally, one girl named Millie said, "Let's call 911. "Hello, this is 911. What's your emergency?" Millie says, "Someone's got bitten by a snake bite, and it's really bad." The 911 operator says, is he unconscious?" And Millie says, "Yes."
Okay, and then the 911 dispatcher says that they'll come right away. Doctors treat this snake bite with antibody, and then James wakes up and he's good to go.
I'm going to be discussing the different parts of the heart. Blood comes from throughout the body. It enters the heart through the vena cava and is pumped into the right atrium. Blood is pumped into the right ventricle. From the right ventricle, blood is pumped into the lungs through the pulmonary artery. While in the lungs, the blood receives oxygen and discards carbon dioxide, which turns into bright red. Then is pumped back through the pulmonary vein.
Then the heart pumps the blood into the left atrium. From the left atrium, blood is pumped into the left ventricle. Then the left ventricle pumps the oxygen-rich blood through the aorta and back out to the entire body.
Stop it!
No, a minute.
You know I'm right.
No, you're wrong. Now you know what I mean?
You were right. Blood drops do appear larger from taller heights.
See, I told you.
But you don't know that because blood drops are unpredictable. Did you really have to waste my cranberry juice? That was limited edition.
Oh, sorry, bro. Sorry.
During this week, we did research on how blood drops would look when dropped from different heights. These blood drops look most like the blood drops that we dropped at 30 inches away from the ground, which means the person would have had to be bending over.
A mysterious powder was found at the scene of the crime. Right here I have the powder along with 4 other substances: powdered sugar, baking soda, cream of tartar, and cornstarch. We will try to see which one the mysterious powder matches with. Right in each dish we have 3 compartments. 1 with the powder itself, 2 with the powder mixed with iodine, and 3 mixed with vinegar. As you can see, the iodine compartment of the mystery powder is the same as the iodine compartment of the cornstarch, but different than all the others. The vinegar compartment and the powder compartment are the same as the cornstarch too. So now we know that the mystery powder is the cornstarch. Another way to tell the powders from one another is by finding their pH level. I will show you how to do that. First, you take a little cup of water, and I'm going to use baking soda as my example. You put the popsicle stick in, and take a little bit of baking soda, and drop it in. Next, we stir it up, and we stick this little pH stick in. It turned green. If we hold it up to this pH level chart I have right here, we can see that baking soda has a pH level of 9. Good.
Action.
Today I will talk about the 3 different types of fingerprints and compare them to the fingerprints at the scene of the crime. So there's 3 different types of fingerprints: arches, loops, and whorls. First I'll talk about arches. You can have arches 5% of the chance, and they have ridges one side to another. And now I will talk about loops. So loops are the most common fingerprints you can have. They are 60 to 70% chances, and they have many ridges, 1 or more, and then they go on either side. Then now I will talk about whorls. Whorls occur around 25 to 35% chance, and the ridges make turns. And the fingerprint found at the scene, it looks more similar to the loops, so it's the most common fingerprint. Each of the 4 suspects, that one, it looks like it is Dr. Nicholas Smart's fingerprint. So, based on all the evidence our STEM group has submitted, we believe that Dr. Smart and shipwright Nev are guilty of stealing the ancient map.
After your hard work in analyzing all the evidence, I decided to conduct 2 final interrogations. First, I interviewed Dr. Smart to hear his side of the story. He denied knowing anything or having any involvement in the crime. His hand was cut deeply and required 12 stitches. It is still wrapped. I then went to Neff's office to interview him. I spied his toolbox and asked him to open it. He reluctantly did, and inside was the missing map piece. He was caught red-handed. Neff broke down and admitted everything. He explained how Dr. Smart approached him before the voyage and convinced him to help steal and hide the ancient map in exchange for a piece of the treasure. In detail, he described how he was desperate and easily persuaded by Dr. Smart's plan to steal the map and cash in the treasure. Unfortunately for Young, she happened to walk by right as Neff and Dr. Smart were arguing about where to hide the map. Hastily, Neff placed the torn map piece in his toolbox. Dr. Smart convinced Neff to then kidnap Young until they could escape with the map. Neff lured Young off the ship by asking for her help to find some important equipment that had been blown off the ship in the storm. Upon our return home, Dr. Smart and Neff will be put on trial and will hopefully be brought to justice by a jury using all the evidence you discovered.